Hello, Tor Lacey here. This is a presentation about the Mesozoic Era, and I hope you enjoy it. The Mesozoic Era includes three periods, the Triassic, Jurassic, and Cretaceous, and spanned 251 to 66 million years ago. Entering the Triassic, Pangaea was fully assembled, but by the end of the period, tensional stresses had started pulling it apart. Evaporite deposits from this time reflect linear rift zones that developed as Pangaea rifted apart and deep fault block basins developed. These were intermittently flooded by seawater from the newly forming Atlantic Ocean. As the seawater evaporated, evaporites, such as rock salt and gypsum, accumulated in these basins. Rifting continued throughout the Mesozoic and continues today as seafloor spreading along the mid-Atlantic ridge. During most of the Triassic and Jurassic, the climate of North America was arid. The warming climate continued through the Cretaceous, which was accompanied by rising sea levels. During the mid to late Jurassic, the transgressing seas led to the partial flooding of North America, forming the shallow Sundance Sea. By the late Cretaceous, most of the American Midwest was flooded by the ocean. Early in the Triassic, the microcontinent of Sonomia collided with North America. This mountain-building event, the Sonoma orogeny, resulted in adding significant mass to the western edge of North America. As North America and South America started to diverge from Africa and Europe in the mid-Triassic, a subduction zone that extended from Alaska to the southern tip of Chile formed. Along the subduction zone, islands and microcontinents, along with thick wedges of seafloor and seafloor sediments, were episodically sutured to the western margin of the continent, further expanding its size and driving the building of mountains. One of these episodes in the mid-Jurassic helped build the Klamath Mountains of Northern California and Southern Oregon. Subduction during this time also generated a long chain of volcanoes and the magma that became the granite of the Sierra Nevada mountains in California. A basin formed to the east of the new mountains, into which the ocean transgressed, forming a shallow sea. This shallow sea was eventually filled by sediments shed from the mountains to the west, replacing the shallow marine environment with a terrestrial one. Over the next 10 million years, rivers, lakes, and swamps provided the habitat for a wide variety of dinosaur fauna. The sediments deposited in this basin cover a large part of western and midwestern North America as the Morrison Formation. Today, the Morrison Formation is famous for hosting a rich assemblage of dinosaur fossils. Interestingly, the strata deposited atop the Morrison Formation contain entirely different types of dinosaur fossils, attesting to the mass extinction event that defines the end of the Jurassic period. During the Cretaceous, volcanic activity, along with mountain building, migrated eastward, resulting in the Sevier orogeny, building mountains in Utah, Colorado, Idaho, and Montana. Ferns were the most abundant flora of Triassic landscapes. These were surpassed by gymnosperms, like conifers and cycads, during the Jurassic. The Cretaceous saw the rise of angiosperms, flowering plants. Like gymnosperms, they produce seeds, but angiosperm seeds are encased in a fruit and contain endosperm that serves as nutrition for the embryo. The Mesozoic Era is often referred to as the Age of Reptiles or the Age of Dinosaurs. But at the end of the Triassic, dinosaurs were inconspicuous. The Triassic could be thought of as a transition period, with synapses, the dominant land animals of the Permian, trying, along with reptiles, to recover from the end of Permian catastrophic mass extinction event. Theropses descended from synapses, like pelycosaurs. It is thought that they were warm-blooded, with hair, making them possibly the earliest form of mammals. Most theropses didn't make it through the Great Dying, however, but one group did, cynodonts. They thrived in the Mesozoic, and it was from this group that the first true mammals evolved. Cynodonts may have been similar to monotremes, like the modern-day echidna. The dominant land animals of the Triassic were a type of crocodilian called Rauisuchians. Rauisuchians were originally thought to be dinosaurs because of their similar anatomies. They walked upright, and some looked like several types of theropod dinosaurs, such as velociraptors. Anatomically, The principal reason for the similarities were its hip joint, which, like dinosaurs, allowed it to move about in an upright stance. However, the hip joint of dinosaurs is open, as opposed to Rasuchians, which is closed at the top. Its ankle joints were structured differently as well, making them a descendant of archosaurs, just like dinosaurs, birds, and turtles, but part of a group that branched off from these more familiar animals. Flying reptiles, called pterosaurs, evolved during late Triassic time. These small bird to small airplane-sized flyers have mistakenly been called dinosaurs, but, like crocodilians, represent a different branch of the reptile family tree. One type, Quetzalcoatlus, had a wingspan of around 35 feet. The age of the dinosaurs begins in the Jurassic. Although dinosaurs lived during most of the Triassic, it wasn't until the Jurassic that they became the dominant terrestrial animals. Dinosaurs are distinct from the similar-looking Rasuchians of the Triassic in that they had open hip sockets and were warm-blooded. Initially, it was thought that dinosaurs were ancient reptiles, but over the past few decades, we have come to believe that dinosaurs were warm-blooded and therefore not reptiles. Mammals evolved shortly after dinosaurs. In order to not be outcompeted by them, dinosaurs must have matched their metabolic rate, which would allow them to match them in agility. The ratio of carnivores to herbivores in dinosaur communities was comparable to what we observe today in communities of mammals. Dinosaur tracks indicate that they took long strides like mammals do. Dinosaur bones show that they hosted a concentration of blood vessels comparable to mammalian bones, not reptilian bones. Like birds, dinosaurs also appeared to sit on their eggs. Dinosaurs appear to have grown much more quickly than reptiles do, and some dinosaurs had feathers, which would have served as insulation for small, warm-blooded animals. Finally, some dinosaurs lived in cold places near the South Pole, where they wouldn't have been able to survive if they were cold-blooded. Dinosaurs are organized into two groups, Ornithians and Saurischians, bird-hipped and lizard-hipped dinosaurs, respectively. This is an edited version of the dinosaur family tree from your textbook that highlights the two types or orders of dinosaurs, the 5 main groups of dinosaurs, and some examples of dinosaurs that belong to that group. Let's review each of the 5 groups or suborders. Therophorians were ornithians that evolved armor and spikes for defense. They were herbivores and walked about on all 4 limbs. Marginiocephalians were a group of ornithian herbivores with frills surrounding their heads and spikes protruding from their brows or frills. Most walked on all 4s, but some were bipedal. Sauropods represent the largest, heaviest, and longest creatures to ever walk the earth. These plant-eating Saurischians probably needed to constantly graze in order to power their immense bodies. Ornithopods were ornithians, herbivores that used their forelimbs for grasping their food. They adapted to a wide variety of ecosystems. Consequently, their fossils can be found all over the world. Like all meat-eating dinosaurs, theropods were part of the Saurischian order. These nimble predators were able to move about quickly on 2 legs, ranged in size from that of a chicken to up to 60 feet long. They had short forelimbs that were used for grasping prey or mating, and some had feathers. It is from theropods that birds evolved. Some of the most important groups of marine life of the Mesozoic included bivalves, gastropods, ammonoids, brachiopods, sea urchins, hexacorals, bony fish, sharks, and swimming reptiles. One of the most successful swimming reptiles were Ichthyosaurus. Ichthyosaurus arose from the aftermath of the Great Dying at the end of the Permian and evolved from terrestrial reptiles that returned to the oceans. One of the greatest mass extinction events marks the end of the Triassic. This coincided with a period of rapid global warming that was likely brought on by intense volcanic activity related to the breakup of Pangaea. Volcanic activity is associated with continental rifting, and the breakup of Pangaea was rifting on a global scale. Volcanoes erupt CO2, methane, and water vapor, all of which are greenhouse gases. These gases trapped the heat that led to the global warming. The extinction event that defines the end of the Cretaceous period, as well as the end of the Mesozoic era, is often called the KT extinction, K being the abbreviation for the Cretaceous period and T for Tertiary, the first period of the Cenozoic era. There is abundant evidence to support the hypothesis that a large meteorite, about 6 miles in diameter, struck Earth at the tip of the Yucatan Peninsula. At the same time dinosaurs went extinct, 66 million years ago. The impact caused a chain of events that killed off the dinosaurs, as well as ammonites and many species of plants, marine life, reptiles, and mammals, making it one of the most devastating extinction events in Earth's history. The shock wave from the impact was comparable to that of 10 billion atomic bombs and would have generated the largest ever tsunami. A huge volume of microscopic debris was blasted high into the atmosphere, shrouding Earth in a thick cloud of dust. As this material rained back to Earth, friction from falling particles generated enough heat to temporarily warm Earth's atmosphere to oven-like temperatures. This flaming hot debris sparked wildfires across the Americas. Acid rain would have accompanied this debris because sulfate from the impacted rock reacted with atmospheric water, creating a global acid rainstorm. Any organisms lucky enough to have survived this apocalypse then would have experienced a months-long period of darkness because of all the dust and aerosols suspended in the atmosphere. Without sunlight, Earth's temperature dropped as much as 13 degrees Fahrenheit. Finally, this relatively brief period of cooling was followed by prolonged global warming, because the rock at the impact site was mostly carbonates, like limestone. The disintegrated carbonates would have added huge volumes of CO2 to the atmosphere, trapping heat and causing the global warming. In summary, the Mesozoic era saw the breakup of Pangaea and generally warm climates and rising seas. Mountain building was happening in western North America, where landscapes were dominated by conifer forests, with flowering plants beginning to take hold. It saw the decline of theropsids and the rise of reptiles and mammals. Dinosaurs ruled throughout the Jurassic and Cretaceous, until a meteorite wiped them out at the end of this exciting era. Thank you for listening.